Hello students, so this is lecture number 2 of the chapter vectors. Of course, in the previous lecture we had discussed about the introduction of the vectors, right? Like why vectors are needed and types of vectors, how to represent a vector, right? What is head of the vector, what is tail of the vector. Fine. So today in this video we'll understand that what happens when a scalar quantity is multiplied by a vector quantity, and we'll also learn about the addition and subtraction of two vectors. Okay, see, suppose in the previous lecture we had discussed that vector is represented by arrow. This is known as head of the vector and this is known as tail of the vector, right? And the length represents the magnitude of a vector. Okay, let us say this vector is of any 10 centimeter, okay, 10 centimeter or 15 centimeter, whatever. So 10 is the magnitude, the length of this vector will be 10, right? And this is the direction. Suppose there is another vector b which is equals to k times a, where k is any constant. Let us suppose the value of k is 2, right? So now we'll draw another vector b which is k times a. That means k times vector a. K is any constant whose value is 2. So your vector b will be k, that is 2, a, that is 10. So your vector b will be 20 centimeter and it will be in the direction of a. So this will be your vector b. It will be in the same direction as that of a, and the magnitude of b will be 20 centimeter. So when a positive constant is multiplied by the vector, it becomes that many times. That means in this present case, when your vector a is being multiplied by any constant 2, your new vector will be 2 times of vector a, but it will be in the same direction if the constant is positive. Suppose your vector b which is equals to minus ka, where k now will be minus 2, k will be equals to minus 2. So now your vector is being multiplied by a constant whose value is negative, right? So b vector will be automatically minus 20, right? Minus 20. So your vector a was in this direction and the magnitude was 10. So now your vector b will be minus 20. That means now you need to change the direction. That means your head of vector b will be opposite to vector a and tail will be here. Clear? This was your vector a, this is your vector b. Vector b is minus 2 times of a, right? So in the direction your first vector was, you just have to reverse the direction of another vector when it is multiplied by a negative constant. If it is multiplied by positive constant, you need to just increase the magnitude that many times, keeping the other vector in the same direction as that of first vector. Clear? First k was positive constant, so another vector was in the same direction as that of a, right? But it was twice the vector a and along the same direction. Now your constant is negative. Of course the magnitude will be the same, 20, but since constant is negative, so you have to reverse the direction of the other vector. You need to draw the other vector in a direction opposite to first vector. So in your first vector this was the head, so now this will be the head. Clear? It is because you multiplied a negative constant. So this is the effect which occurs when a vector is multiplied by a positive constant and a vector is multiplied by a negative constant. Fine. Now we'll discuss the very important topic, addition and subtraction of two vectors, right? Just as we were adding 3 plus 4. The same rules, the same laws will not be obeyed by vectors, because if a force of 5 Newton is acting in this direction, if another force of 5 Newton acts in this direction, we cannot say that a force of 10 Newton is acting in this direction or in this direction. No, we cannot add 5 plus 5 directly because the direction is not the same. Yes, if both the forces are in same direction, if two vectors are in same direction, they can be added up directly like scalar. But if two vectors are in different direction, just as a force of 5 Newton is in this direction and a force of 5 Newton is along this direction. So this, I cannot say the resultant force is 10 Newton along this or the resultant force is 10 Newton along this. No, right? So vector addition needs to be done differently. It will not be done as we were doing by adding scalar quantities. How we were adding scalar quantities? How we were adding mass, length, speed? We cannot add to force, to velocities. No, right? So how vector addition is performed? First we'll look at that. Okay, see. Actually, there are two methods of addition of vectors. First one is addition of vectors. Addition of vectors. It can be done by two ways. Graphical method. First we'll learn about graphical method. Then we'll go for analytical method. Right? We can add two vectors by two different methods. Graphical method, analytical method. Today we'll discuss about graphical method. Of course, for that you will need a pencil, you will need a scale, you will need a compass. Okay, so graphical method is being classified into two: triangle law of addition and parallelogram addition. Two methods, they have specified two methods, right? Once again, addition of two vectors can be done by two ways. Graphical method. First we will discuss few questions and we will understand the method of graphical. Then analytical method. What is analytical method and how to add two vectors with the help of analytical method? We will discuss it later. Okay. First let us add two vectors by the method of triangle. Triangle law of addition of two vectors. It is also known as triangle law of addition of two vectors. Clear? See. Suppose. Okay. Triangle law of addition. Let us suppose two non-zero vectors, vector A, vector B. Right? You can draw two vectors in any direction, right? Again, the question also two vectors can be given in any direction. You have been told to find A plus B. See, both the vectors are not in same direction. They are neither opposite nor they are parallel vectors. Both of them are non-zero. Okay, we have been told to find A plus B, add two vectors. See how this addition is performed. Draw vector A, first vector. Okay, you can have your starting point, there is no problem. You can draw from here, you can draw from here, you can draw from here. Make it sure you cannot change the magnitude, you cannot change the direction. So without changing the magnitude, without changing the direction, draw a vector A. That means the magnitude of this, the length of this vector should be equals to length of this vector. Vector A, the head of the vector A is in this direction, so your head should be also in the same direction. You are just place vector A here. Clear? Now this is your vector B. This is your vector B. With the help of pencil, scale, etc., etc. This is your vector B. Place this vector on the head of the first vector. Right? First measure this vector, measure the length of the vector with the help of scale. And just place this vector, tail of second vector on the head of first vector. You will not change the direction of second vector, you will not change the magnitude of second vector, just place your second vector on the head of the first vector with tail of second vector on the head of the first vector. That means you will place your vector B this way. I haven't changed the direction, it is the same direction. I haven't changed the magnitude, I have just placed the second vector, the tail of second vector on the head of first vector. Clear? Now, from the tail of the first vector to head of the second vector, draw this vector. Make it sure that two heads should touch each other. This vector is addition of A and B, A plus B. This is how two vectors can be added up. We'll see other examples also, so it will be more clear to you. Clear? So this is how you need to add two vectors, and see it formed a triangle. So this is triangle law of addition of two vectors. Is it clear? You just have to draw the first vector as it is. You don't have to change the magnitude and direction. Just place the second vector, the tail of the second vector on the head of the first vector. That's it. And then considering the tail of the first vector, draw the resultant vector this way, such that the heads should touch each other. So this length, that will be the magnitude of A plus B, and this will be the direction. Direction will be known by finding the angle theta. Right? We'll discuss it later on. I'm just explaining you how to add two vectors. That's it. Clear? Clear? Now, suppose you have been told add B plus A. Come on. Fine? You have to add B plus A. Let us consider your first vector as B and your second vector as A. Your first vector is B, your second vector is A. Okay. So what I need to do is, I need to draw the first vector without changing the magnitude, without changing the direction. So my first vector now is B. So I'll just place B over here. Yes, you can draw. So you can draw the vector B from here. From here there is no problem, but make it clear that you will not change the direction, you will not change the magnitude. Right? So your first vector is B, which is in this direction. So this will be your first vector B. Right? I have just placed this vector as it is. I know slight angle variation will be there because I am not drawing with the pencil or scale. Okay. Now my second vector is A. It is in this direction. Okay. So put the tail of second vector on the head of the first vector. So this will be your vector A. Now from the tail of the first vector, draw the tail of the resultant vector, and head should with head. You need to draw the arrow. They are very compulsory. It shows the direction. Right? So this will be your B plus A. See, A plus B is in this direction, B plus A is also in this direction. If you will measure with the help of scale, the magnitude, the length of A plus B will be equals to length of B plus A. From this, we can conclude that A plus B is equals to vector A plus B is equals to vector B plus A. Clear? Clear? And this method is known as law of addition of triangle. Law of addition of two vectors by the help of triangle method. Fine. See now, if this is vector B, this will be also vector B. This is vector B, this will be also vector B. They are known as equal vectors. We had discussed in the previous lecture. What are equal vectors? Vectors whose magnitude is same, whose direction is same. So I didn't change the magnitude, nor I have changed the direction. So if this is vector B, this will be vector B. If this is your vector A, this will be your vector A. So this is parallelogram. This is addition of two vectors with the help of parallelogram. Clear? Similarly here also, this is vector A, this is vector B. Got it? So you can add two vectors with the help of triangle method or parallelogram method. Clear? Clear? Okay. See, let us take one more example of addition of two methods with the help of graphical. Addition of two vectors with the help of graphical method. Suppose this is your vector A, and this is your vector B. Come on. Vectors can be inclined in any direction. This is your vector A, this is your vector B. You are being told to find A plus B. So first I will draw the vector A in the same direction as originally given. I will not change the value, I will not change the direction. Okay, so this will be vector A. So this will be vector A. See, I haven't changed the magnitude nor I have changed the direction. I have just placed the vector A here. Now your vector B is along this direction. Right? The only thing you need to take care about is place the second vector, tail of the second vector on the head of the first vector. So this will be your vector B. I have just placed this vector on from the head of the first vector. Taking the tail of this vector, we will draw the resultant. Head should coincide. This is A plus B. Got it? Clear? For the same question, if we have been told to find B plus A. So first I will draw the vector B. This will be vector B. Yes? Right? This is vector A, which I will draw from the head of the vector B. I will place the tail of second vector from the head of first vector. Clear? This is vector A, this will be vector A. Now, we will join this. So this is B plus A. See? Again from the diagram, it is clear that A plus B is equals to B plus A. Right? Right? This is how vectors can be added. Now let us see how to subtract two vectors. Subtraction of two vectors A and B. It's very easy, subtraction of two vectors. See, suppose there are two vectors A and B. Come on, now we have been told to find A minus B. First, A minus B can be written as A plus minus B. Yes, we can write A minus B as A plus minus B. Okay, fine. This is your vector A. Draw or just place the vector A as it is with same magnitude and along the same direction. Now, originally this is your vector B. This is your vector B in this direction. Arrow is in this direction. So minus B will be this way. Vector A is along this direction. So minus A will be along opposite direction. Right? So if this is your vector B, so minus B will be opposite to B. So this is your B this way, then minus will be this way. Clear? This was your vector A, this is vector B, and minus B will be, this is minus B, because originally B was this way, so minus B will be this way. Right? Now A plus minus B. A plus minus B. From the tail of the first vector, I will draw the tail of the resultant vector and two heads should coincide. This is A minus B. Once again, what I have done? This was your vector B. So this will be minus B. This was A. Clear? So again from the head of the first vector, I will draw the tail of another vector but opposite direction. Because if this was vector B in this direction, then minus B will be this way. So this is your A minus B. Clear? Clear? Okay, now if you are being told to find B minus A for the same question, once again B minus A can be written as B plus minus A. B plus minus A. So now B is your first vector, draw it as it is. This is your vector A. This is your vector A, this will be minus A. This is vector A, this will be minus A. So now from the head of the first vector, we will place the tail of the second vector, but it should be minus A. Minus A, so it will be in this direction. Minus A. Done? Clear? This was your vector B. I will draw it as it is. This was your vector A, so minus A will be opposite. So this will be B minus A. Okay, so now from both the diagram we can say that A minus B is not equals to B minus A. Yes, it is not equal. Why? A minus B is in this direction. B minus A is along this direction. They are opposite to each other. Of course, I can say it as A minus B is equals to minus B minus A. Clear? Clear? Right? So, A plus B is equals to B plus A. But A minus B is not equals to B minus A. Clear? This is how, and here, this is how we'll understand, or this is how addition and subtraction of two vectors are done. Clear? In the next lecture, we'll discuss about what is unit vector, what is null vector, and we'll solve the questions along, or we'll solve the questions of unit vector. Thank you.